So in 6.5, when we were talking about duality of confidence intervals, we already did one problem where we did the confidence interval and sort of said, what would it tell us about the hypothesis test? And so now we're going to work through one where we do the hypothesis test and then say, what is this going to tell us about our confidence interval? And that's exercise 6.5.2. So 6.5.2, we start with our hypothesis test. We can tell because all 5 steps are laid out for us and they're asking us to test a claim. And all the pieces we're used to seeing here are here. So we have some hypothesized value. We have some evidence to test that particular value. And we do want to look around for some sort of keyword here in terms of a direction. And the only keyword that we have is different. Now, we don't want to get distracted by the above 1200 because that's our success in this sort of experiment. And we really just want to show that the local school board's claim is incorrect as this rival school board. So what we're looking to do, H naught, is P is equal to 0.85. Basically, this is the local school board is correct, right? That their claimed value is the right thing. Our alternative is that they are incorrect. It's just not equal to that value. I don't even care which way it is, just not equal to, and that's that the rival school board's claim is then correct. So using the wording of the sentence here, it needs to be, you need to be careful when you get down to step 5. If you just say that the claim is correct or incorrect, you need to be very specific which school board we're talking about. Again, since we did enough problems working through all the steps, I'm just going to use the calculator shortcut here. We have stat over to tests, 1 prop z test again. We want to know how different is 0.85 from our value if we have 97 successes out of 125 students. And we are doing a two-tailed test. So remember, as soon as you have this two-tailed test, if you are somebody who's doing this by hand, you're putting your times 2 in the p-value spot so you don't make any mistakes. Those of us with a calculator, it's already going to do this for us. And this time, I'll go ahead and use the draw button. It's going to give me my next 2 steps anyways, but it will allow me to visually see what's going on. So we draw this. Ooh, not a whole lot shaded. We see our test statistic is negative 2.2. 2.2. It's 2.32, right? 2.32. And our p-value from both those tables already is 0.0205. So this is one where if you did this by hand using the tables, you're obviously going to end up with a different value because this isn't even. This is a little more accurate than what you'd get out of the table. So it looks like we didn't actually figure out what our p hat was, but whatever it was something below what our hypothesized value was. That's what that z is telling us. And then we want to make and justify our decision. So how does that p-value compare to our alpha? And we can see, okay, well, 0.02 is less than that very conservative or not conservative value of 0.10, which means we can reject the null. Our p-value is low, so we get to reject the hoe. And our statement would start with, there is enough evidence, or there is sufficient evidence, right, that the true, and here's where we have lots of options. Option number 1, we could write the local school board claim is incorrect, right? Their claim was that it was 0.85. We just showed that it wasn't 0.85, right? Not based, based on our hypothesis test. Option number 2, that the rival school board suspicion. How do I spell suspicion? Why did I use this word? That is terrible. Oh my God. Suspicious. Suspicion is correct, I guess. I just used the word suspicion because that's what was in the word of the question stem. So that will be the same thing, right? Or option 3, I could use this wording and say that the true proportion of students scoring above 1200 on the SAT is not equal to 0.85. So again, this one was the wordiest. I probably wouldn't have done that, but it means that I'm definitely not going to make a mistake. Where here, I think it was a lot easier to make a mistake, but not so bad as long as we really think we're trying to say alternative in words, and we have a lot of options here for how to do that. So this was the third option. So 3 different ways you could have correctly done this problem. And now to get to the real point of this question, which was how does the hypothesis test inform our confidence interval? Since we were doing this with an alpha of 0.10, the corresponding confidence interval, right, would have a confidence level of 90%. And we're just asking, sorry, I have a little fruit fly in here. It's like they've followed me from 418, for those of you in my latest class. We want to see, would this interval contain 0.85? Is 0.85 inside our confidence interval? And since we rejected the null, this would mean that we would find it outside, right? This is what we talked about at the beginning. This is what you guys discovered on the worksheet. So no, the answer is no. And I'm going to be super lazy here. I'm just going to write this. In theory, we'd probably want to write something out like, no, we just determined that the true value isn't 0.85 at a 10% significance level, so the corresponding confidence interval would not contain that as a value, otherwise we couldn't have rejected the null. But this is it. We go both ways. It does say to go ahead and verify by calculating the confidence interval, so we'll just do that pretty quickly using, again, calculator shortcuts. So stat, and we'll go past the test all the way to the interval. What were our numbers again? I never wrote them down. 97 out of 125. 97 out of the 125 with a confidence level of 0.9. So 0.85 should be outside of this value, and we can see 0.71 to 0.84. I'll round it a lot because I don't care so much for this one. But yes, 0.85 would be outside of that particular range, which is exactly what we expected.